Okay, so in this video we're going to have a look at density, mass, volume questions where we've got these mixtures of materials and mixtures of densities and how we're going to approach these sort of questions. So grab a piece of paper, grab a pen, make some notes. I'm going to kickstart with this question here. So this question says Zara mixes 150 grams of metal A and 150 grams of metal B to make 300 grams of an alloy. And it says metal A has a density of 19.3, metal B has a density of 8.9. Work out the density of the alloy. So an alloy is just a mixture of metals, but ultimately we're mixing two things together and we're creating this new metal here, which is called an alloy when there's a mixture of metals. So we've got the density of the two metals and we have two masses up there of 150 grams. So throughout this topic we are going to be using the density formula, and don't forget the density formula, okay, a little trick for you here, is given to you in the units. You've got the units there, look, grams over centimetre cubed. Grams is a mass, centimetre cubed is a volume, it's mass over volume. So our formula for density is density equals mass over volume. There we go. And for the purpose of this video, I am not going to be rearranging the formula. I'm just going to use a formula triangle. It's just nice and quick because we're going to be using this formula quite a lot in lots of different ways. So I'm just going to use a little formula triangle. So that's density. That's not a D. There we go. Density equals mass over volume. I think I was writing my speed, distance, time one there when I wrote that. Right, so we can put that into a little formula triangle, and we're just going to use this throughout the video. Hopefully you're already well aware of how to use it. If you're not, essentially, if we want to find density, we cross out density, and it's mass over volume. If we want to find the mass at any point, we cross off the mass, and it's density times volume. And if we want to find the volume at any point, we cross the volume off, and it's mass divided by density. So there you go, there's a quick little 30-second on how to actually use this formula triangle. But you should be aware of how to rearrange the formula anyway, but it's just a little bit quicker for us. So when we've got this type of question here, there's a lot of information. And basically what we want to do is we want to remove all the information from the question and just tidy it all up and have a look and see what pieces we've got for which metals and which total this combined mixture. And I'm going to do that in a very specific way, and this is just my way of doing it, but I like to put it into a two-way table. So all I'm going to do is I'm going to draw a little two-way table, obviously a little bit different to a normal two-way table because down the side I'm going to have density, mass and volume. And along the top, I'm going to have my three items. So I've got metal A, I've got metal B, and then I've got my alloy, which is the mixture of the two. I'll just label that as alloy. Right, so having a look at the question, and let's see which information we've got so far. Let's get rid of that. Right, so we've got 150 grams of metal A. So that is a mass. So that's going to be 150 in my mass of A. We've got 150 grams of metal B. Again, that's another mass. And we know that that's a total of 300, and even if it didn't tell us that in the question, which it does, we can add those together. Okay, masses can always be added together and so can volumes. It's just the density part we're going to have to discuss. So it says metal A has a density, and let's swap colours here. Metal A has a density of 19.3. So in density we can put 19.3. And metal B has a density of 8.9. There we go. So unfortunately we can't add those together, okay? Thinking about density, I always like to think about a squash scenario. If you have like an orange concentrate and a water, if you mix them together, the density of that liquid, the sort of cloudiness of the drink is somewhere in between the concentrate and the water, okay? And the more squash you put in, or the more concentrate you put in, the darker that liquid gets and the less opaque it is and less see-through it is. Okay, so what we're going to have a look at is how we find the density of this here, because we can't just add them together or anything like that, even though we can add together these masses and we can ultimately add together the volumes. In order to get the density of the alloy, remembering our formula over here, density is mass over volume, we are going to need the mass of that alloy, which we have. We've got that it's 300 grams. I don't know why I swapped to that, there we go. We've got that it's 300 grams, just there, but we are missing the mass, so we need this, we're missing the volume, so we need to find out what that number is just there, and we can get that by finding the volume of the other two. Now when it comes to these types of questions, this is quite an interesting one because there is the same mass of both, okay? So you might be thinking we can try and find an average at this point, but the volumes are not necessarily going to be the same, so we need to find out what those volumes are. So coming over to our formula, if we cross off volume, it's mass divided by density. So on both these steps I'm just going to do the mass, okay, which I've got here, 150. I'm going to divide it by 19.3. So I'm just going to do that to the side. This one here, we've got 150 divided by 19.3. There we go, and let's work that out. 150 divided by 19.3 on the calculator gives us quite a nasty decimal. Normally it will say how to round it. This particular question doesn't, so I'm just going to round it to 2 decimal places. Although if a question doesn't say how to round it, you definitely don't round it. But for the purpose of this, I'm just going to round it to 2 decimal places. So there we go, 7.77. And if you're wondering what units goes with that, always just have a look in the question. It's always given to you in the densities there. So the density said it's grams per centimetre cubed. So that would be 7.77 centimetre cubed. I'm going to do the same again for the other volume. So for this column B here, I'm going to do 150, divide it by 8.9. And that gives me 16.85 to 2 decimal places. So 16.85. There we go. And now we've got those 2 volumes, we can add those 2 together. So for that final volume of the alloy, we're just going to do 16.85 add 7.77. And that gives us a total there of 24.62. So 24.62. And on these types of questions, obviously I'm minimising the amount of working out that I show, but do make sure you show this working out here for both of them. Even though it's all quite nice and tidy in a table, do show that working out to the side, okay, because those sorts of things are worth marks. Now for the final part of this question, we can now actually get the density. We've got the mass, we've got the volume, so all I need to do is mass divided by volume. So my final bit of working out here is going to be the mass, which is 300, divided by the volume there, which is 24.62 centimetres cubed. So 300 divided by 24.62 gives me a final answer of 12.19, if I round it to 2 decimal places, grams per centimetre cubed. Now the decimal does come out as a lot longer than that, it's 12.185,21527, so I would write down the full number there and keep all the numbers if it didn't say how to round it, but these questions that we're going to look at now are going to tell us how to round it, but we're just not really worried about that for the first question. So there's our final answer, 12.19, and obviously just take note of the fact that it is somewhere in between the 19.3 and the 8.9, okay? It's sort of not halfway in between, but it's somewhere in between the two, okay? Right, so there we go. That is how we're going to answer these questions. Going to have a look at one more of these before you have a go, and here it is. Okay, so I'm going to do this question a little quicker. So when I see a question like this, straight away we're going to write down density, mass, volume. I'm just going to very quickly use this formula and get everything quickly into a table. So we've got the density of ethanol, propylene, and then it tells us how many litres, don't forget litres is a volume, how many litres of those are mixed to make an antifreeze, and it wants us to work out the density of that antifreeze. So it's very similar to the last question, except this time we've been given volumes instead of masses. So let's just have a look at how we'd approach this. So density, mass and volume, and then we've got the ethanol, we've got the propylene, and we've got the mixture making the antifreeze. I'm just going to call that the total. You could call it the mixture, you can call it whatever you want. Don't forget this table is just your way of organising it. There's no set way of doing this. So there we go, there's our table. So let's start putting our pieces in. We've got the density of the ethanol, which is 1.09. We've got the density of the propylene, which is 0.97. Then we've got 60 litres of ethanol, that's a volume, so 60. And we've got 128 litres of propylene. And it says already that that's combining to make 188, but don't forget we could add that together ourselves if we wanted to. So it wants us to find the density of the antifreeze. Now we've already got the total volume, so we need to just work out the total mass. So come into our formula, don't forget to work out the mass. Look, we cross off the mass, and it's density times volume. So for this one here, we're going to do 60, the volume, times 1.09, the density. So 60 times 1.09 is 65.4. There we go, so 65.4 is our mass. And if you want to know what the mass is, obviously just look back to the units. It's grams per centimetre cubed up there. So there we go, we know that's in grams. Our next one to the side, we've got 128 to do. Let's have a look, this one here. Multiplied by 0.97. So 128 times 0.97. And there we go, 128 times 0.97, and that gives us 124.16. There we go. So that gives us a total mass now. We can add those two together. So 124.16 plus 65.4, and that gives us 189. There we go, 0.56. There we go. So having a look at what we've got so far, we've got a mass of 189.56 grams and we have an amount of litres, 188 litres, okay? Now this actually wants us to work out the density of the antifreeze. Now the previous ones were given to us looking centimetre cubed, they're at the top, so this is in centimetre cubed and then the number down the bottom is in litres. Now, we actually, because this is all going to be kept in proportion, we don't actually have to worry about converting between the centimetre cubed and the litres, okay? So what I mean by that is if we were wanting to change these units, we could actually turn the centimetre cubed into millilitres or litres there, but as long as we keep them all in the same units here, everything is going to stay proportional, and actually we don't need to worry about actually converting the units here. Although you could actually go about doing so, but I think if we don't need to, then there's no point in making extra work for ourselves. So the final step for this question, now we have the total mass, now we have the total volume, it's just to actually go about doing our mass over volume to get this one here. So our mass is 189.56, our volume is 188, and if we do that on the calculator, divide that by 188, we get the answer 1.00829, and a few more decimals, but this question does say this time to round it. So we want to give your answer correct to 2 decimal places. So if we chop that after the second 0 there, we've got an 8 afterwards, so our answer would be 1.01. There we go. And in terms of our units here, that is in grams, which is our mass, per centimetre cubed, and that is our final answer for that question there. Obviously keeping our answer in centimetre cubed, as we obviously used our densities as centimetre cubed in this particular question. So that's the end of that question, and here's a couple for you to have a go at. Right, okay, so there's 2 questions here, so pause the video there, have a go, see what you get, and we'll go over the answers in a sec. Okay, so for this first one then, let's have a look at what we've got. So we've got a density, mass and volume down the side. We've got liquid A, liquid B, and it's making liquid C. All right, there we go. And let's see what pieces we actually have here that we can actually fill in straight away. So we've got the density of liquid A, which is 0.7. We've got the density of liquid B, which is 1.6. And then we've got some masses. We've got 140 grams of A and 128 grams of B. And that's going to make liquid C. Well, straight away we can add those together. 140 plus 128 gives us 268 grams for the total. There we go. Now we can start working out these volumes. So don't forget to write down your formula triangle. Density, mass, volume. Volume is mass over density. So 140 divided by 0.7 is 200. So we get a volume of 200 here. 128 divided by 1.6 gives us a volume of 80 for the one next to it. And then they can be added together to give us a total volume here of 280. All right, there we go. We can finish this off. We can do density equals mass divided by volume. So the mass, 268, divided by the volume, which is 280, gives us a final answer here, 0.9571428428, and there's a recurring decimal above the 5 and the 8, so there's a recurring pattern there of 571428. This question doesn't say how to round it, so that would be my final answer there, and that is a density. It's in grams per centimetres cubed. There we go, and that would be my final answer. And obviously if the question doesn't say how to round it, you just leave that as the full number there. Okay, on to the next one. So we've got an orange drink that's been made by mixing some orange concentrate with water, and she mixes 15 centimetre cubed with 250 centimetre cubed of water. Right, so let's start plugging these in then. So we've got the concentrate, we've got the water. Which one's mentioned first? It's the concentrate, so I'll just say orange. We've got the water, and it is making this drink. There we go, so I'll just call it the drink. Again, you can call it whatever you like, but let's just start putting these pieces in. So we've got a density, a mass and a volume to find. Right, okay, so what's given to us in the question then? Now straight away we've got 15 centimetre cubed of orange concentrate, so that is a volume, and we've got 250 centimetre cubed of water. So combined together, that is 265. Have a look at the density. We've got a density of 1.2 for the orange, 1 for the water, or 1.0. And we want to work out the density of the drink, so we can get the masses for both of these now. So don't forget, mass is density times volume. So for the first one there, this one here. I'm going to do 15 times 1.2, and that gives me 18. There we go, and the units there are grams. The next one, we've got 250 times 1, so that is 250. And then we can add those together, and they add together, they make 268 again. There we go. Right, so finishing it off, we can get our density, mass divided by volume, so 268 divided by 265, and that gives us 1.011. It wants it to 2 decimal places, so 1.01 grams per centimetre cubed. There we go, and there's our final answer, 1.01 grams per centimetre cubed. Right, okay, let's have a look at a couple that are slightly different to these two. Okay, so this question here isn't really too much different in terms of the process that we're going to take, but what's different here, look, is we've got apple juice, we've got fruit syrup, and we've got carbonated water, and they're all getting mixed together to make a drink. Okay, we've got this drink getting made. So the only thing that's going to change in this one, look, is that when we draw our table, we've got 3 things. We've got the apple juice, we've got the fruit syrup, which I'll call F, we've got the water, and that's going to be mixed to make our total. Okay, so we've just got a few more columns to be looking at. We've still got density, we've still got mass, we've still got volume, we're still going to follow the exact same process, but our table's just a lot bigger here. We've got that one extra column. So if we start putting all these bits in, I'm going to do this quite quickly. We've got the density of the apple, which is 1.05. We've got the density of the fruit syrup, which is 1.4, and we've got the water, which is 0.99. Then it says we've got some volumes here. So looking for our volumes then, we've got 25 centimetre cubed of apple juice, so we've got 25 down here. We've got 15 centimetre cubed of fruit syrup, so 15, and we have 280 of the carbonated water. And it does actually give us the total. Look, it says it makes a total of 320, so we don't even have to add them all together. There we are, so 320 is our total. And then it wants the density of the drink. So thinking about this very quickly, density, mass, volume, we're working out the masses, which is density times volume. So the first one now I'm doing 25 times 1.05, and that's 26.25. So we'll stick that in there, 26.25. The 15 is going to be times by the 1.4, so that's 21. And the 280 is going to be times by the 0.99, and that gives me 277.2. There we go, you can just about fit that in, there we go. So we can add those all together, get our total mass. So we've got 277.2 plus the 21 plus the 26.25, and that adds together to make 324.45. There we go, 0.45, and there's our total mass. Now, just like all the other questions, we can finish this off. Density is mass divided by volume. So 324.245, divided by 320, and that gives us a final answer of 1.0139 and a few more decimals, but it says here it wants it to 2 decimal places, so our final answer is 1.01. It's a 3 after the 1, so there we go, and that is grams per centimetre cubed. There we go, and there is our final answer. Now we're going to have a look at a slightly different question. Well, it is going to be a slightly different approach, not necessarily 3 columns, but maybe you're going to see that obviously this can be given to us in a slightly different wording here. We're going to have to just take a little bit of a different stance to it, so we'll have a look at that one now. Okay, so reading through this question, it says liquid A has a density of 1.42. Then it says 7 centimetre cubed of A is mixed with 125 centimetre cubed of B to make liquid C. But then it gives us the density of liquid C. It says liquid C has a density of 1.05. Then it says find the density of liquid B. So it's a little bit different to before, look, because it's not asking us to find the density of the final liquid. It's asking us to find the density of one of the ones that was mixed in with it. And that's absolutely fine. Let's just draw our table, start plugging the pieces in and just see where we end up. Let's not worry too much about what's going to happen here. Let's just see what is actually in the table and how we can approach it. So we've got a density, a mass and a volume. We've got liquid A, liquid B, liquid C, and then we'll just start putting in these numbers. So we've got liquid A with a density of 1.42. Later on in the question there, it gives us the density of liquid C, which is 1.05. And ultimately, we're trying to work out this one here, liquid B. So it also gives us some volumes. We've got 7 centimetre cubed of liquid A, and that's being mixed with 125 centimetre cubed of liquid B. Now we can add those two together, so that gives us a total of 132 centimetre cubes in total. So what we're going to do, look, is have a look at what we actually can work out. So we can work out the mass of A, and we can work out the mass of C. So that's fine for us to do. We've done that on all the other questions. So density is mass over volume, mass is density times volume. So we're going to times them together. So 7 times 1.42 for the first one. So 7 times 1.42, and that gives us a total there of 9.94. There you go, so 9.94. And the other one there, we've got 132 multiplied by the 1.05. There we go, and 132 times 1.05 is 138.6. There we go. Now, here is the slight difference here. So we can work out the mass of B now, but we're not going to add those numbers together because B was one of the ones being mixed in. C is our total mass. So in order to get that one there, let's just put a little star next to that. I'm going to do the working out over here. We would have to subtract those masses. So I would do 138.6. and I'll take away the mass of liquid A, the 9.94. Okay, there we go. So if I work that out, 138.6, take away 9.94, we end up there with 128.66. So 128.66. So that must have been the mass of B that was mixed in. So let's put that in there, 128.66. So slightly different approach there, just having to work backwards slightly, thinking about one of the ones in the middle. So now we can finish the question off. We can work out our final density here. Remembering density is mass over volume again. So the mass is 128.66 that we've just worked out, and the volume is 125. So 128.66 divided by 125 gives us a density there of 1.02928. There we are, and it wants it to 2 decimal places. It's a 9 after the 2. So our final density for this question, let's see, where can I write this? There we go, it's going to be 1.03. And again, units are in the question, grams per centimetre cubed. And there we go, there's our final answer, rounding that to 2 decimal places like the question's asked. Right, there we go, so that's how you approach a question if some slightly different information is given to you, just thinking about the fact that you can subtract to go back to one of the previous weights or one of the previous volumes. But there we go, here's a couple of questions for you to have a go at. Okay, so here's 2 questions, so pause the video there, have a go, and we'll go over the answer in a sec. Right, okay, so this first question, we've got 3 different metals being mixed together to make an alloy. So we've got one of our larger sort of tables to draw here. So what have we got? We've got lead, we've got copper, we've got tin, and that is being mixed to make the alloy. And there we go, let's just call that alloy. Right, okay, so let's see what we've got for each piece. Have we got a density, have we got a mass, have we got a volume? So let's have a look. We've got 74 grams of lead, that is a mass, so 74. 100 grams of copper and 126 grams of tin, and it already tells us that that adds up to 300. There we go, so there's our total mass. Then it gives us our density. It says lead is 11.34, it says tin is 7.31, and it says copper is 8.96. There we go. So we've got all our densities. All we need to do is work out all those volumes. So again, density, mass, volume. Volume is mass divided by density. So for that first volume, I'm just going to go left to right. 74 divided by 11.34. And we get some pretty horrible decimals here. So we get 6 and it wants the answer to 1 decimal place. So I'm going to leave them all to 3 decimal places. 5, 2, 6, if I round that to 3 decimal places. 100 divided by 8.96 gives us 11.161. Again, rounding that to 3 decimal places, and 126 divided by 7.31 gives us 17.237. Let's have a look, 17.237, and again, just rounding that to 3 decimal places. Okay, so we can add those all together. So we've got 6.526, add 11.161, add 17.237. There we go, add those all together, and we get a total volume here 34.924. Right, so we can finish this question off now. Last little step, we just need to do the mass divided by the volume. So in mass divided by volume, we've got 300 divided by the 34.924, and it gives us an answer here of 8.59. It wants it to 1 decimal place, so 8.6 grams per centimetre cubed. There we go, and I've rounded that off in my table. So 8.6 grams per centimetre cubed as our final answer there. Right, let's just try and move this out of the way, give myself a bit of space for the other one. Right, there we go. So on to the next one. We have got A and B being mixed together to make liquid C. So let's draw a little table. A, B, C. And let's have a look and see what we've got. Density, mass, volume. Okay, so filling in the pieces that we've got then, we've got liquid A has a density of 1.36. We've got 25 centimetre cubed of A, so that's a volume, so 25 centimetre cubed, mixed with 215 of B, and that's going to make liquid C. So straight away we can add those together, that's 240. There we go. Then having a look, we've got liquid C has a density of 1.01, so that's going to go there. And find the density of liquid B and correct to 2 decimal places. So we can get the mass of both of these, so mass is density times volume, so 25 times the 1.36 gives us 34 for the mass of A. We've got 240 times the 1.01, and that gives us 242.4. There we go, for the mass of C. Now we can work out the mass of B by taking those away, obviously going back to one of the previous ingredients. So take away 34, gives us 208.4. There we go. Right, so we can finish this off now. Density is mass divided by volume, so 208.4 divided by 215 gives me a density of 0.97 to 2 decimal places, 0.97, there you are, grams per centimetre cubed. Right, and there we go, there's our final answer for that one. Right, okay, one more question then with something slightly different for you to have a go at before we finish. Okay, so for our final question, we've got something a little bit different. Now I'm going to run through this one, but feel free to have a go. Now we'll just read through this one. It says liquid A and liquid B are mixed together in the ratio 2:13 by volume to make liquid C. Then it gives us the density of liquid A and B, and it says a cylindrical container is filled completely with liquid C, and the cylinder has a radius of 3 and a height of 25. Work out the mass of the liquid in the container. So it says, give your answer to 3 significant figures and you must show all your working. Now obviously this sort of question here, we've not been given the actual volume of either of the liquids, but it has told us that it's a cylindrical container. So if we sort of imagine what this sort of looks like, we've got a cylinder, okay, it's got its base, there we go, as best drawn as I can, there we go, and it's got a height of 25 and it's got a radius of 3. There we go. So obviously to know your volume of this shape, you need to know your formula for the volume of a cylinder. So if you're not sure of that, the formula for the volume of the area the formula for the volume of a cylinder is volume equals pi r squared, the area of the base, multiplied by the height, pi r squared h. So that should be enough information there, if you didn't already know that, to go about actually working out the volume of the cylinder. Then there's a little bit of ratio up here to figure out the volume of each of those liquids. So you should be able to get the volume of liquid A and B then, and go about this question as normal in a two-way table. So if you do want to have a go, pause the video there, have a go, and we'll go over the answer in a sec. Okay, so first things first, we need to work out the volume of this cylinder. So working out the volume, we've already got the formula there. Volume is pi r squared times the height. So we've got pi times 3 squared times the height, which is 25, not equals, times 3 squared times 25. There we go, and that gives us a volume, which comes out as 225 pi. Now you can turn that into a decimal if you want, but I just think for the purpose of this and to make sure we don't get any rounding errors, it's actually easier for me to leave that in terms of pi, but certainly don't feel like you have to, but it's just going to make it a little bit easier as we go along just to leave it in terms of pi. So there we go, there's my volume in terms of pi. Now getting my volume now in for A and B, it says it's in the ratio 2:13. So we've got 225 pi that needs splitting in the ratio 2:13. And we can go about doing that, look, we can just divide that by the total there, which is 15. So if we divide that by 15, and then we can split that in the ratio. Now 225 divided by 15 gives us 15 pi. Again, you could leave it as a decimal if you want, but then I'm just going to times that straight out by 2 and 13. So we've got A to B. 2 times 15 pi is 30 pi, and that's our volume. And 13 times 15 is 195 lots of pi. There we go. So there's our volumes in terms of pi, and again you can write that as a decimal if you want, but let's just go about actually drawing our table here and seeing what we've got. So now we've got our volumes, the rest of the question's just the same as before. We've got A, B and C, and we need a density, a mass and a volume. And ultimately, what's the question asking? It's asking us to work out the total mass of the liquid. So we're looking to get the mass of C, this box just here. Okay, so let's start filling in some of these pieces. So we've got the density of A, which is 1.21. We've got the density of B, which is 1.02. And now we've got our volumes in terms of pi. We've got 30 pi for the volume of A and 195 pi for the volume of B. And obviously that gives us a total there of 225 pi. There we go, 225 pi. So we can go about working out some of these masses now. We can get the mass of A. Remember in our formula, density is mass over volume. Let's just write that up here. So to get a mass, it's density times volume. So I'm going to do 30 pi, and I'm going to times it by 1.21, and that's going to give me the mass there of A. So 30 pi times 1.21 doesn't give me a nice number in terms of pi this time, so I'm going to turn it into a decimal. Now the question says give your answer to 3 significant figures, so for the purpose of my work in here, I'll leave it to 5. So we've got 114, and that's 0.04 to 5 significant figures. And if I do the same for the next one, B there, 195 pi multiplied by the 1.02. Again, that doesn't give me a nice amount of pi, so I'm going to turn that into a decimal again to 5 significant figures. We've got 624.86 to 5 significant figures. And there we go, we can actually just finish this question off now. Look, we can add together those two masses. We don't need to work out the density of C, but we can add together the two masses. Look, and we get 738.9 as our mass there. Now it wants it to 3 significant figures, so we're going to round that to 3 significant figures just to finish it off, and that'll be 739. Having a look at the question, what's it about? It's all in grams, so 739 grams would be our final answer for this question. And also thinking about where you could actually take this question a little bit further, we could even work out the density of C. Obviously it doesn't ask for it in this question, but we could do mass divided by volume now. We could do that 738.9 divided by the 225 pi, and we actually get 0.045. Okay, and a few more decimals. Not that we need it for this question, but obviously if it did want that, and say, let's say it was 3 significant figures as well, we could get 1.05 grams per centimetre cubed for the density of that. But there we go, that is the end of that question. That's the end of densities when we're looking at mixtures. So that is the end of the video. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.